In today's lesson, we will be exploring tables and graphs of ratios and rates. Ratios and rates show the relationship between two quantities. In ratios, the quantities have the same unit, while in rates, they have different units. We use ratios and rates all the time. Think about 40 miles per hour. This means we move 40 miles for every 1 hour we travel. Since these quantities have different units, miles and hours, this is a rate. On the other hand, let's consider how we cook rice. You use 2 cups of water for every 1 cup of rice. Since these quantities have the same unit, cups, this is a ratio. Let's take a look at how ratios and rates can be displayed as tables and graphs. Here's an example of a rate. The new season of the television show Friends in Fernville was just released. Carrie watches 2 episodes in 40 minutes. The rate is 2 episodes every 40 minutes. Here's a table that represents that rate. Let's examine it more closely. We can see the original rate written in the first column of the table. If Carrie watches 2 episodes in 40 minutes, she can also watch 4 episodes in 80 minutes. Those 2 rates are equivalent. You can make an equivalent rate by multiplying or dividing both parts of the rate by the same number. In this case, we multiplied both values by 2. To get from 40 to 120 and from 2 to 6, we multiply by 3. And finally, for our last value, to get from 40 to 160 and from 2 to 8, we multiply by 4. So all of these rates are equivalent to our original rate, 2 episodes in 40 minutes. Ooh, I see another interesting pattern. In each rate, we can multiply the episodes by 20 to get the number of minutes. That's because the time to watch 1 episode is 20 minutes. We call that a unit rate. We should be able to find a pattern like this in any table of equivalent rates or ratios. Let's look at the graph of these values. The minutes are the x values, and the episodes watched are the y values. Each of the points represents a rate from the table. For example, our first point is 40, 2. It represents the first rate in the table. In 40 minutes, Carrie can watch 2 episodes. The next point, 80, 4, represents that in 80 minutes, Carrie can watch 4 episodes. That's the second rate in the table. The same is true for the other 2 points. 120, 6 represents the 120 minutes it takes to watch 6 episodes. And 160, 8 represents the 160 minutes it takes to watch 8 episodes. Notice these points are forming a straight line that starts from the origin, which is the point 0, 0. This will always be true. Whenever we graph equivalent rates or ratios, we will always get a straight line that goes through the origin. Let's look at some examples. As we practice, we will be able to see how the ratio, the table, and the graph are all different depictions of the same thing. When working with equivalent ratios, remember to always look for multiplication patterns in your table and a straight line through the origin in your graph. Let's work through the first problem. At Diggy's Doggy Daycare, dogs get both outdoor and indoor playtime. For every 10 minutes of outdoor play, they get 20 minutes of indoor play. We want to create a table and a graph to represent this ratio of 10 minutes of outdoor play for every 20 minutes of indoor play. In the table, we can see the outside minutes are multiples of 10, 10, 20, 30, 40. So the inside minutes must be multiples of 20. We can fill out the table 20, 40, 60, 80. Let's make sure we've made equivalent ratios. 10 times 2 is 20, and 20 times 2 is 40. 10 times 3 is 30, and 20 times 3 equals 60. 10 times 4 equals 40, and 20 times 4 equals 80. They're equivalent. Did you notice in each ratio, the number of inside minutes is 2 times the number of outside minutes? That's because for every 1 outside minute, the dogs get 2 inside minutes. Since that is true for all 4 ratios, that also tells us they are all equivalent. Okay, let's get these ratios plotted on a graph. The outside minutes are on the x-axis, and the inside minutes are on the y-axis. We start by plotting the point 10, 20. So we go over to the x value, 10 outdoor minutes, and up to the y value, 20 indoor minutes. We repeat this for the next 3 points. Over to 20 outdoor minutes, up to 40 indoor minutes. Over to 30 outdoor minutes, up to 60 indoor minutes. And finally, over to 40 outdoor minutes, and up to 80 indoor minutes. We can check our work by verifying that we're forming a straight line that starts at the origin. Looks good to me. Our points are plotted correctly. Let's look at another example. The principal at Orchard Ridges High School signs each graduate's diploma by hand. It takes him 30 seconds to sign 4 diplomas. Let's fill out the table and graph. This time in the table, we aren't counting by multiples, so the best way to fill out the table is to check each rate. Remember, to get an equivalent rate, we need to multiply or divide both parts of the rate by the same number. From 4 to 12, we multiply by 3, so 30 times 3 equals 90. From 4 to 20 is multiplying by 5, so 30 times 5 equals 150. And from 30 to 210 is multiplying by 7, so 4 times 7 equals 28. And our table is filled with equivalent rates. Let's plot the points. We have seconds on the x-axis and diplomas signed on the y-axis. To plot the point 30,4, we go over to an x value of 30 seconds and up to a y value of 4 diplomas, and we have our first point. We repeat this for the next 3 points. 90, 12, 150, 20, and 210, 28. And look, we're forming a straight line that starts at the origin. Perfect. That makes me wonder though, could I use the graph to fill out the table rather than the table to fill out the graph? Let's try that approach in the last example. Winnie's Wings offers a rewards card. With every $50 spent, customers can choose 2 free appetizers. In this last example, we have a restaurant that gives away 2 free appetizers for every $50 spent. Let's fill out the table and graph for this rate. As I indicated in the last example, I want to try to start this problem with the graph instead of the table. On the graph, the x-axis is the amount spent in dollars, and on the y-axis is the number of free appetizers earned. We can plot that first point that was given in the problem. We go over to $50 and up to 2 free appetizers. We know that all of the equivalent rates will form on a straight line through this point in the origin. From my table, we know that the next point should be at 6 appetizers. If we follow the pathway of this line to where the y value is 6, we see the x value is $150. We place that point on the graph, and while we're at it, we can fill in our table as well. We get 6 free appetizers after we spend $150. Our next point should be at 8 appetizers. If we continue on the line, we see that when the y value is 8 appetizers, the x value is $200. We need to spend $200 for 8 free appetizers. So we plot that point and fill in our table. And finally, we want our last point at $250. We follow the line again. This time, we want to find where we have an x value of $250. That's when we have a y value of 10 free appetizers. This way, we're able to fill out our table and graph at the same time. As you can see, we can make tables and graphs to represent ratios or rates. Using these representations interchangeably gives you a lot of problem-solving strategies to choose from. This allows you to use the tool that works best for you, and that's what being a mathematician is all about. Keep practicing, and good luck.